part of NATing in the Palo Alto Firewall. Till last video, we were discussing about source NAT, right? So first of all, when starting this section, we understood about NATing in detail. Then there are two types of NATing, right? That can happen in the Palo Alto Firewall. One is source-based NATing, source NAT, and the destination NAT. So till last video, we were discussing about different types of different methods of source NAT practically, right? So in this video, let's understand about the destination NAT and how does it work. All right. So before that, all right, as we cannot use our pen within the RDP, maybe I just took the snap of our topology to our PC. All right, that's fine. So generally, destination NAT will be used when the request is initiated from the outside or untrusted network. Okay, say for example, when the request is coming from the internet towards any destination in the trusted zone. Okay, trusted zone or the trusted network. Okay, and the reason why we are using destination NAT is, say for example, this is one of the PC. Okay, this is one of the user from the internet. Just consider he is an outside zone, right? Just consider he is a user coming from internet, and you have one service that's placed in the inside zone, and you want users from outside zone to use it. Okay, but at the same time you don't want its IP address to be exposed in the public internet. Okay, you don't want to expose its IP address in the internet. So in that case, you will be using the destination NAT. So what happens when users from the outside, right, from the internet, it's coming, they'll be pointing towards the interface IP of the Palo Alto. Okay, so as per them, means to say, for example, if we just consider that this is one web server like example.com or whatever it is, right? So in the DNS, what happens, they'll be mapping this IP address instead of this actual IP address. It would be a private IP address. Okay, it may be a private IP address also. Mostly it would be a private IP address. And in the DNS, what happened, you'd be mapping a record, you'll be adding a record to the Palo Alto interface only. So whenever a user from the internet, he want to access this particular website, right? So when the DNS resolution happens, it will be providing the IP address of the Palo Alto interface. Okay, this is how they'll be adding, they might have added the record. So users traffic would be coming here, and also as per user, he may not aware, right? He don't know that to which device he is connecting. As per him, he want to connect to the example.com, and whatever IP address he is received from the DNS server, right? That is the actual destination. But it will be a interface IP address, the outside facing interface IP address of the Palo Alto firewall. So what happened when the actual request comes from the user from the untrusted zone or the internet zone or whatever it is, we will be having a NAT profile. We would be having a NAT profile which would translate from this IP address towards this, and it will forward the request to this particular server. All right, and we'd be getting a response from the server, and again it be translated and will be sending from here. Okay, so this is how the destination NAT will be working. Okay, so I'll repeat again, the destination NAT will be commonly used. Okay, commonly used when a request, it is coming from a client request is coming from the untrusted network or untrusted zone like internet. Okay, because you don't want to expose your internal IP address or the IP address of the actual server to the internet. You want to keep it privacy, or you want to keep it secured. Okay, so that's the reason you will not expose it. Instead, what you will do, you will write a NAT policy here, NAT profile here, and you'll be adding this particular interface to the DNS record for this particular server. Okay, not for the internal transaction, I'm referring for the external. Okay, for the public. So what happened when the client request is coming towards this particular interface, it gets translated to this actual server interface. All right, and there are a couple of methods also, means as like you can do port forwarding as well. Okay, maybe we'll be discussing that practically in our lab. And there is another scenario also. One is the destination NAT in Palo Alto Firewall. There are two methods you can do, two types. One is a static, means One is a static. You can point an IP address to a particular server, or else you can also do a kind of distribution. Means just consider that. So in this case, the static method is okay. Means so whenever a traffic that is coming from any client, you can make in such a way that whenever a traffic is coming from any client pointing towards this IP, translate to this server. Okay, this is one method. And there is another method where you just consider that you have some 3-4 servers here, which is replicated for the same service, the same example.com. Okay, but you're having multiple servers. Okay, in that case, you can also use a kind of a load balancing, right? So the user's traffic would be coming here, and as you have a multiple servers, it would do the load balancing. It would distribute the traffic, the sessions evenly based on it has a load balancing algorithm as well. It's similar to the load balancer. Okay, that's the different method. So basically two methods. One is whenever a traffic is coming from whichever client it is to one particular means pointing to this interface, it will be translated to a specific server. This is one method. The other method is a load balancing. When you have multiple servers acting for the same application, then when a request comes, it will load balance and distribute the traffic. All right, let's see that practically. All right. So before that, I'll just fine. Let's go to our lab. Okay, so we have discussed about this topology, right? So if you compare the topology, I have made a slight modification. I have modified in regards to this particular setup, means this particular destination NAT. So if you refer till last video, means starting from the first video in the NAT section till last video, we used a different setup, like the LAN zone and the DMZ or outside zone, like that. But I made a small changes, as like I brought the server within the inside zone. Okay, and this is the IP address of the web server. Means this is a server, right? So it is the IP address of the server. It's 10 10 10 15. All right. And this is one zone, and this is outside zone, which is referred as an you can consider this as an untrusted zone. Okay, an untrusted network like internet. So here I have an IP address for this user 172.16.0.15, and it is connected to this interface, so 172.16.0.100. And so as you know, we already have the interface configuration, the zone already configured, and also we have a basic security policy to allow any transaction that's coming from either inside to outside or outside to inside, any. Okay, so now explicitly, as we are concentrating on a NAT in this video, we are directly getting into that concept. Okay, I'm not going to repeat again like IP address basic stuffs. All right, so let me go to my Palo Alto Firewall, and I'll just go here. And if you see here under policy, there is something like NAT, right? All right. So I'm just going here, and we need to do the NAT profile here. All right. So in order to create a NAT profile, if you see here, you'll be seeing an option to create a new NAT profile. Or you can just click here, and 1 minute, just make sure it's recording. All right, it's going on. Fine. So I'm just creating a NAT profile. I'll put NAT, or else I'll put destination NAT profile. All right. So it's an IPv4 NAT. That's it. And coming to original packet. So if you remember in the last section, till last video when we are discussing about source NAT, right? So we have one zone as the the source, and the other zone as the destination, right? So when we are doing the source NAT, we have one zone as source zone, and the other zone in the destination. But in the destination NAT, as we said, means basically the traffic is coming from outside zone, and it is pointing towards this interface. If you see, both user is in outside zone, and also he is coming and hitting to an interface that is also part of an outside zone. Okay, so here the source is also outside zone and destination is also an outside zone. So we should be very careful when we are writing a profile for a destination NAT. We should not get confused. However, if you see in the source NAT, maybe that changes, right? It depends on your architecture. Maybe you'll be having inside zone as a source and destination zone as a outside zone for the source NAT. However, when you are doing a destination NAT, as I said, when you go for a destination NAT, basically you'll go for a situation when a traffic that is coming from outside or untrusted network, right? So in that case, already user is also means the user who is initiating a traffic is also in the outside zone, and as per him he knows only this IP address, right? He don't know this IP address. He'll be initiating a traffic only to this IP address. So both source and the destination which it's hitting, that is also same zone. All right, so this is the major difference. So I'm coming here and I'll make a source zone as outside zone and destination zone also outside zone. Okay, and you can have this interface any, but if you want to explicitly specifically add it, so this is the interface. Okay, if you remember in the source NAT, when you put sources inside and the destination is outside zone, if you remember, we made a destination interface as this side, means the interface which is passing out, right? But in destination NAT, that is not the case, because users traffic is hitting to this IP address only, which is configured at this interface. So it's not going beyond that before NAT. Okay, so what we'll do, we'll put 1/2 as the destination interface. All right, and if you want, you can explicitly you can write a NAT profile based on any service, or you can make it as any. I'll just go with any as it is a lab. And generally in a destination NAT, when you define a destination NAT profile for traffic that's coming from untrusted network, you will not specify, because means you will not specify the source address, because it is the internet address, right? So any users may be coming from internet, so you cannot specify it. And again, it depends on your this place where you are applying this destination NAT. But in a general case, I'm referring where I'm telling the user is the traffic that's initiated from the untrusted network, right? So I'm not giving any specific source address, I just made it any. However, when it comes to destination address, as I said, as per user, he knows only this IP address, nothing more than that, right? So destination address is specifically 172.16.0.100. All right, so to this IP only user is initiating a packet. So source zone is outside zone, destination zone is also outside zone, and the destination interface to where the user's traffic hitting is 1/2, which is facing outside zone. And I have not specified any source address, but the destination address is this one, because to this interface only, this IP address only, user's traffic is initiated. I'll go here to the translated packet. Last time, if you remember, we were working on this side, right? We were making changes on this side. But this time, as we want to work on the destination NAT, okay, DNAT, destination NAT, this is the place we want to enable it. So by default, it would be none, which means it's disabled, but you can enable it. So as I said, there are two methods. One is static IP, the other one is dynamic IP. So first of all, I'll just, let's practically see how does the static IP work, and then we'll go for dynamic IP. I'll tell about it. So I'll just select it static IP. So it is asking for the translated IP, which means that means it's telling, okay, let the source be any, which means whoever user that is coming from outside zone hitting to this IP, if the destination IP it's hitted to this IP, to what address it should be translated, that address we should put. So as per our topology, whoever is hitting to this IP, it should be translated to this server IP, right? So I should give the server IP 10 dot 10 dot 10 dot 10 dot 15. Okay, you can also do translated port. I'll show you what's the difference it is. Okay, so for now I have given only the IP address of the this thing, the destination server. I click OK. I'll just click OK, commit OK. So let it commit. In the meantime, I'll just go here, open my terminal, and if you see the server, right? So this is the server, and if you see here currently, it is running with the IP address IP. So maybe I'll just close this window because this is a old screen. IP config. So if you see now, it is having an IP address 10.10.10.15. Also, in the Apache server, we have modified it. If you see here, 10.10.10.15. Okay. All right. So, which means that it is running with this IP and it is listening. It's an web server. All right. Fine. Now let me go and see here. Yep, it's done. Let me go back here and we'll capture traffic on this interface and this interface. Okay, when we initiate a traffic from here, we'll be seeing source address as this and destination address as this, means 172.16.0.100. And if you capture this site traffic, right, if you capture this site traffic, you would be seeing that the packet is translated from a source 172.16.0.100 and to the destination 10.10.10.15. Okay, so let's do that. Right click, capture 1/2. Okay, I have this issue. Mm, okay, 1 minute, I need to do a modification. All right, I disable that HTML console. All right, so now if I go back here, I'll just put capture 1/2. All right, let it starts, and also 1/1. All right, so we started to capture both the side packets, right? So let's do one thing. I'll just go to this machine, this Windows 2 machine. Okay, this machine I am here. This is old session and just close it. So I'll just open this. So basically, this is a user machine from my outside zone. Okay, the untrusted network. What I'll do, I'll initiate few pings. This is old one, maybe to the same IP. Ping 10.10.10.15 to the same. Okay. All right. So I'm getting response, right? And I'll just minimize it. Let's open our web browser. So we'll give 172, sorry, not 172 this time. The server is in the inside zone, right? So 10.10.10.15. Okay, I'll hit enter. Fine. So I initiated a HTTP request to the server in the inside zone. It is working. It's getting a response, right? Let's go back to our capture and check how does it is. Okay, we'll minimize it, and now let me go back to the capture. We'll stop it and we'll go here. We'll stop both. All right. So first of all, I'll check for the ICMP. I filter with ICMP. If you see, the request is initiated from the IP 172.16.0.1. This is the actual IP address of the user machine in the untrusted network or the outside network, right? And if you see, the destination is 10.10.10.15. Oh, sorry, it's my mistake. Okay, I'm supposed to initiate a traffic towards the point. Okay, it's my mistake. I'm sorry. I'll just close this. I'll just close this and we'll capture once again. All right. Sorry, my mistake. We'll capture it 1/2. So as we were discussing about source net till last video, right? So I was in that direction. So already, which interface we have captured now? Okay, I'll just do one thing. I'll stop it. We'll capture 1/1, which is this side. And we'll go back here, right click, capture 1/2. And also at the same time in the production environment, you will not be having this kind of a connection, right? So if you see now when I try to connect from here to with this IP address, it connected, right? However, in the production environment, first of all, you will not be aware about this actual IP address, and the other one, you will not be, even though it has a public IP address, you will not have policy to allow traffic mostly. All right, I think both the sites it started. Okay, fine. Now let's initiate a traffic. We'll go back to this machine. We already have a session. So instead of 10.10.10 means this is actually the server's IP, right? I don't want to hit to that. Instead, what I need to do, and also if you come to command prompt, right? I don't want to ping to that. So ping, now I want to initiate a ping towards my Palo Alto interface, the interface IP address of 1/2. Okay. So that is 172.16.0.100. So when we initiate a ping towards this, it should be translated. Also, if I open a browser and here if I put 172.16.0.100, okay, if I hit enter, see, I'm getting a response from the web server. Actually, I'm trying to initiate a HTTP request towards my Palo Alto interface only, the interface IP address which is configured in the outside zone. However, I'm getting response from the web server which is within inside zone. So this is how NAT works. Okay, means this is what destination NAT is. I'm giving to this IP, but this destination IP is translated to the internal server IP, and it's working for me, right? Now let's go to the capture and we'll analyze it. Okay, we'll go to this capture, we'll stop here, icmp. All right, so this side, let's go back here and stop it, icmp. All right, see, I'll show you. So if you remember, means we initiated a ping, right? We initiated a ping from user machine from the outside zone towards the firewall interface IP, which is 172.16.0.100. So if you see this capture, all the transaction is between the actual client and the IP address of the interface, right? So we are getting, we are initiating a request and we are getting a reply to it. However, if you look the other side, the other capture, right? So the source is still the same, means it is giving the actual user IP information, but the destination, if you see, right, it is natted to this one, 10.10.10.15. Okay, so the destination IP is translated from 172.16.0.100 to 10.10.10.15. Okay, this is the internal communication from firewall to the internal zone, the server in the internal zone. All right, and also if you look at the TCP stream, okay, I just, all right, and I'll just go the other side as well. We'll close it. If you get to the TCP stream, all right. So this is the TCP stream, right? Means we initiated HTTP traffic. If you see, starting from the TCP three-way handshake, the communication happens between the actual client in the untrusted network. That's 172.16.0.1 to 172.16.0.100, right? The interface IP address. Okay, so there is a three-way handshake happen where source, the client initiated a SYN packet towards the Palo Alto interface, and Palo Alto interface responded with the SYN ACK. It sent a SYN, and also it sent an acknowledgement to the SYN which is sent in the previous packet. And again, the client respond to the Palo Alto interface with an acknowledgement for the SYN. Okay, so the three-way handshake is completed here. And if you see here, 172.16 here, right? So it is using the get method. Means basically it is requesting for the HTTP request. It is initiating, right? It is initiating towards 172.16.0.100 only, which is the IP address we configured in the firewall, right? Firewall interface. However, once we initiate and one session is going on that side, if you see here, we are seeing another session where the client IP is still same, the source IP 172.16.0.1, because we are not doing any source net so far, right? So that the source address is not changed. But if you look at the destination IP address, the actual address which client sent is towards 172.16.0.100, but it is translated to 10.10.10.15, right? So in this session also you'll be seeing a three-way handshake, but this is between this is actually between the internal server. Okay, synac hack, and there is a get message, right? But this particular IP address will not be exposed to the client. Okay, fine, because even when a client runs a capture and if you want to get the information, right, he will not get this. He will be getting only the firewall IP. So this is how the destination IP is getting translated. All right, I'll just close this for now. And if you see here, right, let's go back to the profile. If you see here, when we are configuring, there is something like translated port. Okay, so we can also do port forwarding or port translation, right? Say for example, I'll just go back to my this server. Okay. I'll just go back to the server, and if you see currently the server is listening on port 80. All right. What I'll do, I'll just change this and I'll make it to listen on port 8080 instead of port 80. Okay. All right. So it listens on port 80, right? I make it as port 8080 also for reference here as well. All right. So now it's listening on port 8080 instead of only 80. So if you once we saved and restarted the mission, this will be going and it start to listen on port 8080, so that if you initiate port 80, it will not connect. Okay, so in order to connect with the server, you should initiate a traffic to only port 8080. Only then it will respond. Fine. So now I'll go back. So as I said, now this is listening on port 8080 and 443. Anyway, we are going to test with HTTP only. So for that, it is listening on only 8080. So if I go here now, and last time it was working, right? Last time it was working. Not sure whether I translated. Okay, no problem. So last time when we initiated a traffic, it was working, right? But this time, if I go back here and I'll hit enter, let me check whether does it working. Because at the back end, it is now listening in port 8080. It's not listening on port 80. But now I have initiated traffic on port 80 only, right? So it will be trying to connect for some time, and at last it will get an, unreachable. See, yeah. So it is unable to connect. So basically what happened, it tried to connect with port 80 with this IP address. However, the server is listening on port 8080, which means it's on a different port, right? So in this situation, we may need to do a translation of port as well. Okay, so which means that even when this user initiate a traffic on port 80, in addition to the IP address, how I translate from 172.16.0.100 towards 10.10.10.15, so as same, in addition to the IP address translation, I can also make a port translation. Like when user sends an request with port 80, translate it to port 8080. So that as per user, he doesn't need to initiate a traffic on port 8080. He will be just initiating a request on port 80 only. So once the request hits here, as you know, the IP will be translated to this, but along with that, the port also will get translated from 80 to 8080, so that it can able to connect to the server. All right, so let me show you how to do it. So this is the place where you want to put it. So if in case your server is listening on port 8080, you should mention as like port 8080 here. Okay, to which port does you want it to translate it. Okay, that information to be added here. So this is nothing more. So my the destination is still there. Sources, I have not made any changes, just added the port translate or to translate to this port. Okay, so it depends on whatever service you're running. I'll just commit it now. So if you see here, and before that, before commit, I can show you one more thing. Maybe so it was not working right with only port 80, but at the same time, if you put port 8080, it will work. See, because our backend server is listening on port 8080 only, right? So that's the reason. So far it's not saved, right? It's not committed, but still we are getting a response. We are getting a response here because we initiated a traffic itself on port 8080. So that what happens when you initiate a traffic itself on port 8080 towards it, so the destination would be as like 172.16.0.100 with port 8080. So once it comes here, it will not look on the port, it will only translate the IP address, so that it translated to 10.10.10.15. As it comes with along with the port 8080, it will just directly put it to it, and it is already listening on port 8080, so that it's working, it's sending a response, right? But before that, when you initiated a plain HTTP request on port 80, it is not responding, right? Because it is listening on port 8080. All right, so now it is committed. Okay, let's go back here to the same server and we'll initiate only with port 80, and this time it should work. Okay, just ignore about this 8080. I'll just open up one more window. 170, sorry, it's not 172, it's 10 dot, right? So I'm not giving any port informations now. I'm just hitting. See, I have not given any port informations, but this time without any port informations also it's working for me, because even when I give on port 80, it is translated to port 8080. Okay, if you want to see captures, that also we can do. Maybe I can just right click here, go to capture on ETH1. I can start capture. So let it load, and also if I'll come this side, capture ETH1/2. Right. Now it's listening on both the sides, right? It's capturing on both the sides. We'll go to the client back. So this is the user mission, right? This is a user mission that's coming from the outside zone. Okay. I'll maybe if you want, I can enlarge it. I can maximize it. Okay. I'll go back to my browser. So I'll put 10.10.10.15 only. This time I'm not putting with 8080, just 15. So which means by default it's going with port 80. As we have port translation also, it is translated to port 8080 and we are getting a response. All right. So now what I'll do, I'll just minimize this. First, okay, I'll just close it and we'll minimize this. We'll go to my capture and we'll stop it. Mm, Nothing is there. Free transmissions. Maybe I'll do one thing. I'll just close this because already we have the sessions. I'll just stop and quit. What I'll do, I'll just stop this mission and I will start it again. Right. So we'll go back here. It's loading. So this time if we capture, right, we should see it. Check now. Yeah, it's loaded now. So I'll open this. Just 1, 2, 3. It's loading. It's taking some time. Let's wait. Also, in the meantime, maybe still it loads. We can also go to our monitor and check. Anyway, it was happened, right? It happened. The translation happened, and we saw that it's translated when we initiated a traffic on port 80. It's translated to port 80 entry, and it was working, right? So we can check that. We can check here. See, we can see the transactions. Like if you see here, whenever this one means this explicitly we have initiated with port 8080 for testing. I show you that when we first of all I initiated with port 80, it was not working. Then I showed you with 8080 it was working. So this one, okay, I'll just open any of this one with 172.16.0.1 towards this destination. Not this destination. It should be from the sources from 172.16.0.1 to this one. Or I'll just refresh it. We should see a session from source to dot 100. Okay. All right. Anyway, it's fine. We'll go here. We'll check whether does it loads. All right. So it came now. So we'll open this one IP config just to make sure that it's not changed. 172.16.0.1. So it is having the same IP. Okay. So as per this topology, I put it 15. Actually, it is 172.16.0.1. Okay. Fine. Windows 2 machine. Right. Correct. So before initiating any traffic, I'll just come here. We'll capture ATH1/1 as well as ATH1/2. All right. So now we started capture on both the sides, and we should see traffics. That's fine. Let's go here to this mission. So anyway, we already have a session, right? We'll open any one. Fine. So this is the user mission. If you remember, we can also ping towards 172.16.0.100. Okay. So actually it is connecting to the web server. Okay. I'll just open a browser, maybe a private window this time, and we'll initiate a traffic to 172.16.0.100. Okay, not 8080, just 100. All right, I'm getting a response from the backend server. Okay, fine. So let's go back and check the captures to see whether it got captured or not. Then HTTP get. Okay. Fine. So I'll also go this way. TCP. All right. So this is what I want to show you. If you see here, this is the capture that's taken on ATH1/2. All right. The interface which is connecting to the untrusted network or the client who initiate the traffic, the internet zone. Okay. So if you see here, 172.16.0.1, this is the TCP transactions, right? So basically the HTTP request which we initiated for the IP address 172.16.0.100. So as you know, this three-way handshake happened successfully. And if you see, all the transaction that's happened is between the source, the client, towards the Palo Alto interface IP address, right? And if you see the destination port, right? So this is where the destination port is. So 80, right? So you'll be seeing the transactions between the random source port towards the destination port 80, because we initiated a HTTP traffic. Okay, whatever traffic packet you hit, and if you see here, you'll be seeing from this random port to 80 only, or you can hit any packet. Okay, you can hit any packet and you can see that. Okay, it is going to the port 80. Okay, so you can click any packet that's coming from, this is the client, right? If you can see here also, if someone is not aware about packet capture, you can see from here as well. So this is the client IP, this is the destination IP, and it's a TCP port, and this is the length, this is the source port. Okay, source port which the client uses, and this is the destination port. Okay, so this is what we are referring here, we are interested to see. And you can also see here, okay, the destination port here in the layer 4 header, right? The transmission control protocol, because it's a TCP. Ignore about the source port because it's a random port. Look on the destination port, it's 80, right? So the entire transaction, if you see, it should be between a random port and the port 80 only, because the client initiated a traffic towards port 80, so that we are getting response from port 80. Okay, random port to port 80 and port 80 responding. If you look the other capture that we have taken from this thing, our interface 1/1. Okay, this is post to the translation of IP and port. This time we have set our server to listen only on port 8080, and also we have a profile to translate the port as well along with the IP, right? So it will be translating the 80 port to 8080. See, the random port, I think it's the, if you see, right, the random port, it is 58122. So the entire communication, the client is using this as the source port, and this is the destination port. If you see here, for the client source port is still the same, but if you see the destination port, okay, it is translated from 80 to 8080. Okay, if you'll be seeing all the transaction is between port 8080 and 58122. So which means that the 80 port is translated here to port 8080 along with the destination IP address. If you see here, the IP address is also translated. In the other capture which I showed you now, with when we have referred to port 80, it was to the destination of the firewall interface IP address. However, if you see here, it is pointing towards the server IP address, right? The server's actual IP address. So in this case, both IP address as well as the port is translated. Okay, so this is what I was looking to show you. All right, that's fine. And we can also check that here. If you look, refresh here, let's see if there is something. All right. So we initiated a ping, right? Once we stop and restarted the user machine, immediately we initiated a ping. Okay. Then we initiated a web browsing, right? So this is that ping, and this is the web browsing I was looking to show you. I'll just click it, magnify. Okay, we'll enlarge it. So if you see here, this is the client IP, right? 172.16.0.1. And if you see the destination IP address is 172.16.0.100. All right. So once it reaches to 172.16.0.100, it came with port 80. Okay, and it is translated this IP and this port to this one, NAT IP. If you refer, see 10.10.10.15, this IP address is translated to 10.10.10.15, and this port 80 is translated to port 8080. All right. So this is how the destination NAT along with the port translation works. Okay. I'll just close this for now. Also, if I go back to my NAT profile, I'll go back to my here. So this is the place where you are doing the destination address translation, right? So if you see here, in addition to static IP, you will be seeing something like dynamic IP. Okay, if you remember in the starting of this video, I told that there are two types of a dynamic, the static NAT you can do for two situations. One is where you want to translate from the scenario one, which we have tested now in the lab, right? When you are trying to connect to a interface IP or the IP address of the Palo Alto, and it gets NATed to the inside server's IP. That is one situation. And the other situation is means like that you can have multiple profiles where when the traffic is connecting hitting to the interface IP, it can redirect to, or sorry, translate to some other different service IP. Okay, the other situation is, as I said, means the request that's again coming from the untrusted zone, the internet zone, and behind your firewall, you are having a multiple service, right? You're not having a one server, you're having a multiple service that is providing a service of maybe it's the same service. Okay, you have some 3-4 physical servers providing the same service in all the 3-4 servers. In that case, if you want to do some load balancing kind of a thing also, like similar to a load balancer, how we do, right? Even if you see here, it's mentioned with session distribution, means basically it's distributing the load. So you'll be adding the translated IP here. Okay, and these are the port numbers if you want. And if you see, this is the distribution method, round robin you can make, least session. So these are all the load balancer methods, right? So this is the other method you can do. All right, so mostly you'll be seeing this kind of mapping here. When the user traffic hitting to Palo Alto, the firewall interface, you'll be having a natting towards the server IP. So right, so this is all about the destination NAT. So there is something like UNAT or U-turn NAT, which is quite interesting, but it will not be used in every means. It's specific. It's specific for certain scenarios, for certain situation. Maybe we'll discuss about UNAT in next video. All right. I'll just stop it for here.